If you've come for a simple lesson on the states of matter, you're in the right place. Matter is anything that takes up space and also has a mass. The 4 types of matter that we're going to talk about are solids, liquids, gas, and plasma. Plasma is a little bit of a weird one. Starting off with solids, if we look at this very simple diagram here, this tells us a lot. These individual circles are all particles within the solid. As you can see, they're tightly packed in solids, and because they're tightly packed, they don't move around much, but instead they vibrate. You can think of this like your phone. When you get a notification, your phone vibrates, just like the particles in the solid. Also, solids have a fixed volume and shape, kind of represented by this square here. Solids are not easily compressible. If you were to squeeze one in your hand, it's very difficult to make it into a smaller volume. And lastly, when you think of a solid, we don't think of a solid as being able to flow easily. Solids do not flow very well. Next, we're going to talk about liquids. Once again, looking at this diagram here, we see that the particles in liquids are still relatively close to each other, but they are irregularly arranged. Similarly to solids, the particles in liquids vibrate as well, but they also move around more and slide past one another. Liquids have no definite shape, so if you were to hold a liquid in your hand, it would completely fall out. But they do have a definite volume. If you were to have the liquids in a jar like this, the volume would stay constant. And once again, similarly to solids, they're not easily compressible. If you squeeze them in the hand, it'll be very difficult to reduce the volume. There's a lot of similarities between liquids and solids, which is why they are both called the condensed phases. The reason for this is because the particles within solids and liquids are relatively close to one another. Next, we're going to talk about the gases. Once again, looking at the diagram down here, we see that the particles are well separated. This means that the gases are not one of the condensed phases. Also, the particles have no regular arrangement. The particles in the gases vibrate, but the particles are the most free moving, more free than the liquids and the solids. There's no definite shape or volume of gases. You can think of a fire. The gas coming out of the fire just continuously expands, creating a larger and larger cloud of smoke. And something that's unique to gases is that they are easily compressible. If we add a weight here, kind of like a piston, and we push this gas down, we can reduce the volume of the gases. We cannot do it with solids or liquids. And lastly, because these particles are so separated, gases have the lowest density, much lower than liquids and solids. The kinetic energy of gases are higher than solids and liquids. These particles are moving around very fast, bumping into each other, which keeps them well separated. So you might be asked a question on a test, compare liquids versus gases. First of all, we need to know the density differences between all of the states of matter. Solids are the most dense, gases are the least dense, and liquids are in the middle. This is once again related to the kinetic energy being the lowest in solids for the particles, and kinetic energy being the highest for the particles in gas. If we look at a little Venn diagram here, we see that both gases and liquids are not rigid. So they're not in a fixed shape like solids are. This is what they have in common. But liquids have a fixed volume, while gases have no fixed volume. Remember the example with the smoke coming from the fire. It gets into a bigger and bigger cloud of gas of increasing volume. Liquids have a higher density than gases, as we can see by the particles in these diagrams here. Liquids are not easily compressible, whereas gases, if we add a weight here and push the gas down, we can compress the gases into a smaller volume. This is a good example of a question that you might get on an exam. Plasma is a bit of a weird state of matter, and it's the last one that we're going to talk about. This diagram is a little bit more complicated than the previous diagrams. Plasma is similar to a gas because it lacks a fixed volume and shape. It has quite a few similarities to gases. The unique thing about plasma is that it can conduct electricity and respond to a magnetic field. This is because in plasma there's ions and free electrons. These electrons are represented in the pink here. We can convert gas to plasma if we have enough heat or electricity. An example of this is the sun. The sun is extremely, extremely hot. People say it's a big ball of gas, but it actually contains a huge amount of plasma. The last thing that we're going to talk about are the different processes to get from one state of matter to the other. We're going to write the endothermic processes in red and the exothermic processes in blue. Endo meaning that the process requires heat. Exo meaning the process releases heat. From a solid to liquid, this is called melting, whereas a liquid to solid is called freezing. These are a couple of the more simple ones. Melting something requires heat, so it's endothermic, and freezing something releases heat, so it's exothermic. From liquids to gases, this is called vaporization. You're turning a liquid into a vapor. And then gas to liquids is condensation, kind of like the condensation that you get at the top of a boiling pot of water. And going directly from solids to gases, this is called sublimation, and going the other direction, gases to solids, is deposition. And then talking about plasma, the weird state of matter, going from a gas to plasma is called ionization. You're turning the gas into ions. And then plasma to gas is called deionization, or also known as recombination. I hope you learned something from this summary of the states of matter. If you have any questions, comment in the comment section below. Don't forget to like and also subscribe to The Chemistry Kid for more.